This conference is brought to you by CallStack, your React and React Native development experts.
Is this as good as it gets? You build a form for creating a user, and it works great. And then, down the line, you need a form for updating a user. So you add a boolean prop to your generic user form, isUpdateUser. But updateUser has some differences. It sets the initial state to the existing user, and it shouldn't render the welcome message or terms and conditions. So you pass a boolean for each of those to hide them. Oh, and when the mutation succeeds, it shouldn't redirect to onboarding. And then it happens. You need a component for only updating the user's name. So maybe you create an updateUser_name component. And you pass only editName as a prop. And maybe you need to set isSlug_required to false. And I know if you've written React for long enough, you have a lot of code that looks like this. And I'm sure you don't like peeking inside of user form because it's a complete mess. And the question is there a better way? And to illustrate, I'd like to examine a complex UI component that we're all familiar with, Slack's composer. How would you build this? Now, I don't have any idea on how they actually implemented it, but whenever I use a product this often, I can't help but wonder, how do they organize this UI? And how do they handle their state management? On the surface, this component may seem simple, but it comes in many forms. It's used in channels and DMs, DM threads, channel threads, forwarding a message, editing a message, and a few more. Each implementation has its subtle differences from logic and UI. For most of the composers, the state is actually global, and as you type, it's synced across devices. But for one like forwarding a message, it's actually ephemeral. Now, over the years, I've seen hundreds, maybe thousands, of React code bases, articles, and tutorials. I have seen your code, and I've seen what AI outputs when you ask it to build with React. So to start, I'll show you what I think the typical approach is to building a composer like this. And by the end, I hope you'll come away with a more enjoyable way to write React, one that makes both humans and AI agents productive, even as a code base gets larger. As you build a composer, you'll probably start with something like this. You have a header, input, and footer. And in your channel, you simply render it and pass it on submit. And it looks simple enough. And so our composer for channels is complete. But what about sending messages in a thread? Well, I'll create a thread composer, and I'll just swap out the submit function. And we're good to go, right? But wait, I know you've seen this. The channel and the thread have this tiny difference. The thread composer has this little bar here, which says also send to channel. When you check that box, it also sends your message back to the original channel. We have to account for this in our composer. So maybe you'll just throw in an isThread prop, and of course a channel ID. And it's pretty harmless, right? The thing is, we have two different kinds of threads to consider, DM threads and channel threads. On the left, it says also send as direct message, and on the right, also send to channel. So how would you organize this logic? You'd probably add another condition, like isDMThread and DMID. And it just keeps going. Now, maybe you add some TypeScript tricks to avoid impossible states with unions. But we just know it's going to be a mess. And you have to handle this with yet another ternary. It's a bit messy, but you think, you know what? It looks good to ship. We now support threads, channels, and DM threads. But wait, now we need to do edit message. And there's always that one component that really ruins the day, the one with 30 conditions that you have to check all over the place. And that's what edit message is about to do. On the left, we have our channel composer from before, and on the right, edit message. And see if you can find the key differences between them. First, in the footer, our actions on the left aren't the same. In the edit message, we only have format text and emojis. And in the bottom right, we have entirely different ways of handling submit. Now, it's important to note that when the plus icon on the very far left is missing, that means you can't add attachments. So for edit message, since we don't have that little plus icon, it means we also have to disable dragging and dropping. And how hard can that really be to implement? Well, this is the composer we have now. And most code bases I've seen would add yet another condition. So first we'll disable the drop zone for dragging files. And we'll pass a boolean to our footer to make sure it knows which actions to hide. And obviously, if you can tell by my tone, I don't love this code, but I promise something is better. So we'll continue with the footer. Right now, our footer has actions and submit. It's very simple. But we need to filter out certain actions when we're editing a message. And here's the thing. I know what you might want to do here. You'll probably just have an array of actions. And over time, that array keeps having to handle more and more cases. You add something like isMenu true, and divider true, and a menu items array, but only in some of the items. And you just know the implementation that loops over those actions is a disaster. So, okay, now we need to handle this isEditing message boolean. And this is where it starts. We hide the plus icon, we hide the mentions, everything after it. But what if we just used JSX? We can ditch the array and create a distinct component for each action. And under the hood, each one of these can implement a shared button. But it's easy to escape to something custom when you need it, like the button all the way on the left, which has a bit of a different style. I'm yet to find a better abstraction than just using JSX for UI. I always come back to it. Now, handling this boolean is still a mess, and you could wrap everything in a fragment to give yourself the illusion that the code is maintainable. But at this rate, who knows how many more conditions we're going to add. Oh, and one more thing. The actions in the bottom right for editing are cancel and save, which is totally different from the original composer, which is just this little icon button. So how would you handle that? I think I know. I think that in our edit message composer, you might add on cancel prop. Yet another optional prop that we now have to handle and pass all the way down to our footer. So here in the footer, we basically lose this simple submit button and add another condition with more and more complexity. And just imagine if you have 20 more cases like this. If you're using the same condition this often, all over the place in the same component, you may have found a good use case for composition. In fact, if you have a Boolean prop that determines which component tree is getting rendered from the parent, you can kind of imagine me looking over your shoulder and shaking my head. Now, maybe you can refactor this in a way that feels a little bit simpler with like a render submit prop. But this won't actually work for every composer, as you'll see in a little bit. And this is a story of many React code bases. As they get bigger and their one-off components get reused in all different ways, it becomes hard to work in. I've seen this for both humans and AI. But is there a better way? Can we scale our code bases while retaining the flexibility, but without making it hard to work in? Can we build in a way that both humans and AI can succeed? Well, let's look at one more instance of our composer, forwarding a message. Here we have yet another implementation with its own subtleties. The actions in the bottom left, well, they're almost the same as the edit message composer, except the forward button is a little bit different in the bottom right. There's nothing there. And forwarding also has a mentions icon in the bottom left. Yet another condition there to handle. So we need a way to pass our form state up to the parent for those buttons at the bottom to access it. Because notice that the submit is not inside that composer box. It's totally separate. So do we once again add another Boolean prop, like isForwardingMessage, and then find some way to set state from our form back up to the top so that it goes all the way to this forward button, which is outside of the composer? Well, if we do that and we keep expanding the API, we'll end up with a composer that looks like this. Quite a nightmare to work on. So instead, let's try something new. What if we built our features like Radix components? Instead of this channel composer, which renders a monolith with a giant list of optional props. What if we split it up, starting with the composer provider? And then we can just simply add in the frame, the header, the input, and the footer. And lastly, to support drag and drop, we'll just have a dedicated drop zone file. And that component gets rendered here without a boolean. We don't need any special checks. We just render it or we don't. But given how much customization our footer needs, let's open it up. And inside of it, we'll pass our submit button, which shows at the end, and then we add our actions. Here we have the plus menu, emojis, text format, and more. Now, it's a lot to show on screen, so I hid it, but the thing is, many of our composers actually do use the same actions there in the bottom left. So let's combine these into a component called common actions. This is what our channel composer looks like now. We have a provider at the root, a drop zone, frame, header, input, and footer. And what do common actions look like under the hood? Well, it simply wraps our existing compound components. This way, we get a reusable monolith for the composers that need it. But the crucial part is that we can always escape out to render individual items. And notice that common actions doesn't receive a prop like isEditing message. It doesn't have to do any complex checks itself. Keep that in mind because it'll be relevant soon. So let's continue with this approach. Let's rebuild our composers using composition. I was worried I might mess that one up. Back to the code. If this is what our channel composer looks like, what would our channel thread composer look like? Well, the only difference here is this also send to channel component. So I'll create a new thread composer where the only difference is the name. And the last thing we need to add is also send to channel. Everything else is the same. And this is all we need. And where are the booleans and the special props from the top of the tree telling us what to render? They're nowhere to be found. We don't have a monolith. Instead, we have shared internals that get re-implemented for each use case. And when you have something you want to abstract, such as footers, common actions, of course you can, but we don't always need to. All right, but anyway, those were the easy ones. What about the edit message composer? Well, just like always, we'll start with our provider. We'll add in a frame, header, and input. We will not add the drop zone here because editing messages does not support attachments. There's no boolean to determine this. We just don't render it. And the last missing piece is the footer. Now, this is where things got a bit dicey in the previous composers. And the question is, how do we implement this? Any complex checks or props to pass down through a bunch of components? Well, if you look at the footer in the UI, on the left we have only text format and emoji actions. So let's just render those. We can simply reuse our components we created earlier. Instead of using common actions and passing it some prop, we can just use JSX directly. And what about our cancel and save buttons in the bottom right? Well, those are one-off components, only used by this composer. So we can just render buttons. We don't need some render submit or anything complicated like that. You can just render JSX. No set of millions of props or all these different things. We have completely distinct React component trees, which just rely on JSX to render. And suddenly our code looks like a work of art. And you can imagine that it would almost be hard for AI to hallucinate here. But what about state management? This is the part that I've left out up until now because there are many valid ways to handle this, but I'll show you a general pattern that I like. To illustrate, let's move on to the forward message composer. Something unique about this component is that its state is local. It's rendered inside a modal. And if you dismiss that modal, Slack will warn you that you're going to discard the draft. And that is unlike all the other composers we've seen. You see, the other ones, as you type in the composer, it will actually sync between your phone and your computer. In some cases, the state is synced across devices, and in other cases, it's entirely ephemeral. So we not only have to consider these little differences in UI, but also the fact that the exact same component could have entirely different implementations of state management. So let's implement it to see how it works. Here's our forward message composer using our shared things like the header, input, footer, and 3 actions. And once we close this dialog, that text should not save, so how do we handle that? Well, that's where the provider comes in. The context provider defines the comment interface used by its childrens, including state and actions. But the implementation itself is only handled by the component which renders the provider. Since our forward message modal is ephemeral, in this case, we can just reach for use state. The provider will also define generic actions like update, and in this case, we implement that with setState. But in other cases, you could actually use any state handler you want here. I even like passing a meta property for anything that lives outside of the internal state. For example, you could add an input ref here. Now any component can easily focus the input, and you don't need to pass it down through a bunch of weird places or use imperative handle. You just have it in your context. And the specific naming here just comes down to preference. And so how does this look in practice? Well, the composer input simply uses the context and renders from there. The input is actually agnostic to the state and actions and how they're implemented. It just renders it based on the shared context. And if you're worried about frequent re-renders from React context, just use the React compiler. Really, it's fantastic. I actually could give a whole talk on all the little amazing optimizations the React compiler gives us. And to prove it to you, I actually pasted this component into the React compiler playground, which is a really cool tool that I just use all the time because it's pretty crazy to see what it does. And even though the compiled output here is a bit hard to read, I'll let you take a look to notice that it actually does memoize this input based on only the inputs that we access from the context. Okay, back to our provider. It looks like this, where I also added a submit handler to forward the message. And so that's the only hook that's really sending anything to the network. And just like before, we render our header, frame, input, and all the custom actions in the footer. But wait a minute. What about that row of buttons all the way at the bottom? They are rendered outside the composer. So what do? Do we have to send state from our composer back up to the parent in a use effect? Or do we have to have some shared ref that we call onSubmit, which checks the form state? Well, of course not. You see, zooming out, this is our code right now. And how can we support this row of actions down at the bottom? Do we need some kind of render function, right? If we pass render footer, well, that wouldn't work because that component didn't have anything to render down there. Instead, we need to lift our state. And if there's one thing to take away from this talk, it would be this. I've solved so many problems in my React code bases by simply lifting state higher up in the tree. In practice, that means taking our provider and pulling it into its own component, which receives children. Then we pass forward message composer as a child of the provider. And below that, we can render our message preview component and our actions. And what's so special about this? Doesn't this just look like regular React code? Well, here's the key. The forward button at the bottom can just use the submit action from the context without being inside the composer. Because it's within the composer provider, though not necessarily within the composer frame, it has access to all the composer's actions and logic. I'll say this again. The row below the composer, which is not inside the composer box, can still access its state and actions. There's no need to pass things back up and back down or have any kind of weird thing like onForm state did change. Just like that, we can escape out of our default implementation into a customized one without a heavy lift. We lifted our state and composed our internals. Our final code really looks beautiful. We render UI in the forward message composer, which reuses some of the composer's components, but not all. We have an unrelated message preview component, which can render under it without any weirdness. And we have our custom actions at the bottom, which use the composer's state and actions, but are entirely isolated from its UI. So how might we do the same with the original channel composer? Well, the question is, where do state and actions come from? Use state from React will not work here because our channel composer actually has its state synced across devices. So I'll import a hook called useGlobalChannel. And this hook is in charge of sending messages and syncing it up across the backend and even across devices. And as long as it returns things which can conform to the interface used by the context, it works with this component. The implementation is decoupled from the interface here. And we can swap out our state management with ease. Now, in our channel composer, all we need to do is swap out this root provider. for our new channel provider. And all of its children will now use state that is synced across devices. And if you ever need to change your state management for this entire composer in any one of those implementations, you just have to do it in one place. This is instead of having a global hook that your composer actually queries inside the component, and then you need to do a bunch of boolean checks within that component. It all lives at the root provider. Now the question is, does this matter if AI is going to write our code for us? Are these things just little details that are just days away from becoming irrelevant? I would argue that on the contrary, regardless of where software ends up, the way we instruct it is critical. Suddenly, as I've been using AI more and more, a good code base feels more important than ever. Lately, I've been building the mobile app for V0, and I'm spending so much of my time looking at AI outputs for React. My side project is Chess0, a chess app I built with V0 using only my voice when I go on walks. And I've been feeding V0 slides from this talk, prompting it to rely on composition for its state management and rendering. And I've been amazed at how successful it's been at writing fewer bugs. Perhaps best of all, I love editing the code. For the first time, I found a way to not only vibe code, but pair program with AI. And if you're interested in seeing the prompts I use, you can follow me or reach out on X, and I'll share them there. So the next time you're 15 booleans deep into your component props, just remember, composition is all you need. Thank you.